Right, we're going to try this transformer worksheet, see if we can get our heads around this. So the idea behind a transformer is, let's just try to make it, so you've got a bit of iron, you've got a wire coming in, and it wraps itself around this part. So you've got current and voltage, you've got the voltage coming in here. Oh, and just say it's going out that way. Right, and then on this side, if I've got more turns here, so that's voltage 1, that's number of turns 1, this is number of turns on the coil 2, and this is the voltage 2. I'm going to get more voltage here, a higher voltage here, because there's more turns of the coil, stronger magnetic field, a high induced voltage. This here would be called a step up transformer, because it steps up the voltage. Right, just bear with me. Right, let's so you've got so this is called the soft iron core of the transformer. You have a alternating current being supplied, so you have an alternating voltage, so the voltage travels, pushes that way, and then it pushes that way. The output here, you've got an alternating voltage and current, and the symbol for alternating is a sine wave like this. I think for a direct it's something like this, but don't quote me on that. The first coil is called the primary coil, where the things are going in, and then you have the primary voltage, and the one that's going out is called the secondary coil, and the secondary voltage. Right, and that's what you need to know, and it works off magnetism, because you've got a changing magnetic field, you've got induced voltages. Right, okay, let's just crack on with this. So we need to somehow plot this now. Right, let's just copy that. Put it down here. We now need to somehow plot this, yeah? So at 10 is 39.6 at 10. Number of turns is 10 here. and we need to go 39. Oh, it's almost 40. So there. At 20, it's nearly 20. It's 19.7. At 20, it's 19.7. At this scale, you'll be allowed half a square. At 40, it'll go to 10, 9.9. At 60, it'll go to 6.6. So that's 5. There. 80, it'll go to 5. And 100, it'll go to 4. So what you've got in effect is no, that's not 6.6. Let me be 6.6 is about here. Then you get a pencil. Really at 0, there's no 0, so we're gonna have to live with that. Right, this is the difficult bit. Try to go through every point because so remember you'll be using a pencil, smooth curve. That's not the smoothest thing in the world, but it's done. Right, so we now need to describe the relationship between the voltage output and the number of coils. So as the number of coils increases, the voltage in the output voltage decreases. So it's a step down transformer. So as the number of primary turns increases, the secondary voltage decreases. The voltage output, yeah, that's the secondary voltage, or you can say the voltage output. And it's not a linear relationship. It is a non-linear relationship. Okay. So now we need to learn this formula. So, right, stay with me, I will put a picture up. Right, so you've got, let's just make that bigger. So what you've got is, you've got your primary, where should we dump this? Right, okay, here, let's put it here. So I can write on it. Right, so let's look at it now from here. So this bit here, so it goes round like this. This is your primary coil. Okay, it's got number of turns is, sometimes you get capital N with the lowercase, with the subscript, sorry, P. In this case they've done NP. So your input voltage, your primary voltage is V with the subscript P. You've got this soft iron core linking the two. So this induces a voltage, it travels through, and then on this side the voltage induces the voltage or the current that's traveling along here induces a magnetic field here, which in turn induces a voltage in the secondary coil. They've called it output voltage, but it's voltage in the secondary coil, so it'll be V secondary, and the number of coils, number of turns is N S, number of turns in the secondary coil, or N S. That's what you'll see. Primary, secondary, just get used to those two words, primary and secondary, input and output. So don't get confused with the two. Right, so we need to now learn this formula. He says, right, so state the formula so we can say primary, number of turns on the primary coil divided by the number of turns on the secondary coil equals the voltage across the primary over the voltage of the secondary coil. So linking input output voltages and the ratio for the and the turns. Yeah, so what they mean is this is the turns ratio and this is the input and output. So remember we said input is primary and output is secondary. Just remember that. Once you've got that, you're sorted. Right, the input voltage of the transformer is, calculate the number of turns on the secondary coil. So we know we've been given 10 turns. Okay, can I just move this and cheat? Does it say anything else? So number of turns on the primary coil is 10. So now, should I cheat? No, I shouldn't really. So we know that there is 10. Yeah. So what we're saying is the input voltage, where's the input voltage, is the primary. We know that is 6.8. What else have they given us? The input voltage of the transformer, where's the input voltage? Input voltage is what? 6.8. Oh. Right, 6.8 is here, so so what they've used is, let me just bring that down so we're not going up and down like yo-yos. Right, what they've said is the input voltage is 6.8. Right, what they've said is there's 10. It's getting a bit confused here, so where are we? There. Let's look at this. They've said that we've got 10 coils on the input, so my apologies for this. That's what happens when you cut and paste in bits. Right, you've got 10 coils, so from there we go up with a ruler, we end up hitting what was it, 39.6, which is near enough 40, isn't it? 40. So they've used 40, I think. So we're trying to work out the number of turns, so we're trying to work that out. So the voltage on the secondary, the output voltage on the secondary will be 39.6. They've used 40. because I just rounded it off to make it easy. I don't know. Right, okay. So this is what we've got really. We've got if we just use this in its raw form, let's do it in two ways. So we're saying 10 over ns equals 6.8 over 39.6. And then you say ns equals 10 times 39.6 over 6.8. Right, and we can, where's the calculator? Right, bear with me. Yeah, that gives 58.235 and so on. So, and they've rounded it off to number of turns. You're going to only get 58 turns. You can even say 59 turns. Right, okay. Now, do you know when you've used the sine rule? Because the unknown here is at the bottom here. Let's put it down here. What you do is you flip everything round. So look, I'm going to rewrite this as ns at the top, 10 at the bottom, 39.6 at the top, 6.8 at the bottom. So I should really start with this, and all I do is I multiply both sides by 10 to get rid of that. So I multiply it by 10. That disappears, and that's what I've got down here. Right, that's one way of doing it. So, but it's one of those shortcuts that you've got to internalize. You got to keep practicing so it goes into your head. So this was quite a tough, well, from my point of view, it's hurting my brain. So this is a good way of doing it, because then I appreciate the pain of going through. That's cool. Let's keep going. But I will call it quits here. What we need to do is right, before we go, we need to do this. We need to write, forget the right, let's draw. Right, you've got an iron core. So this is what you've got to learn to do. So I'm sure I've seen a question in the past where they've asked you to draw it. That is your soft iron core on your transformer. You have your primary coil. It doesn't matter how many dots you draw there. So this is your primary voltage, and the number of turns. The number of turns there is your primary. Then you've got your secondary voltage, and the number of turns is NS. There's a formula linking them two. So the number of primary turns divided by number of secondary turns is equal to the voltage in the primary divided by the voltage in the secondary. I don't think you have to do current actually. Not at this level. Right. One other thing now I want you to know. How should we put this? If there are less turns on the primary coil, so if there's less turns here and there's more turns here on the secondary, it's a step up. If there are less turns on the primary coil, then it is a step up transformer. Right, that's it. So learn this structure. Call it quits there.